Welcome back to our grade 10 maths lessons. I'm Miss Ainup, your maths teacher. In our last lesson, we looked at indices. We had a review of indices. In today's lesson, we are going to look at logarithms. Okay? Logarithms. Now, what are logarithms? Logarithms comes from the Greek words logos, all right, and arithmos, meaning a ratio of numbers. Okay, so in the 17th century, a man named Napier came up with logarithms, and he set a method of completing calculations, all right? Over time, logarithms has been used to simplify complex maths problems and to also compress large-scale scientific data, okay? So we're going to look at what logarithms are, where they are used. Now, one place that you should be most familiar with, you covered this in grade 9 when you looked at money, the formula for compound interest, all right? The amount is equal to the principal, all right, multiplied by 1 plus the rate and raised to the power of t, okay? T is the time taken for an amount of money or the principal to be compounded, all right? So the amount of money is increasing at an exponential level, all right? Now, when we covered compound interest, you will find to find the amount, you need to raise to the power of the time taken. Now, sometimes you are asked to find time based on all the other values that are given. Now, you are working backwards to find the time, or you are doing the reverse. In actual fact, you are applying the simple exercise of logarithms, okay? So, index, all right, we are familiar with index. Let's have a look at a term that you should be able to recognize. Y equal to a to the power of x. Now, this is an equation in index form, all right? Index form. Logarithms is the inverse operation or the opposite operation to taking the index of a number, okay? Now, we know that this is the base, okay? And this is the index. This is also known as the logarithm, okay? So all this time you hear logarithm, you think it's a very difficult term. No, logarithm is simply the index or the power, and another term you know is the exponent, okay? So how do we work with logarithms? Let's look at a simple index function here. Y equal to a to the power of x, okay? Y equal to a to the power of x. Now, when we express index form as a log, we are in fact trying to express a number using the base that is given, all right? So if I were to write a in terms of, or y in terms of the base a as a log, I would write, okay, log of y to base a, all right, is equal to x, the index, okay? So when you're looking for logarithm, you are in fact going back to find the index that was used to find the number that is given here, okay? So this is known as equivalent statements in index form and in logarithm form, okay? Now, let's use a couple of numbers here to see how this works, okay? Let's see, 3 to the power of 2 is equal to 9. That's correct. Yes, 3 squared is equal to 9. Now, let's write this as a logarithm. We know that 3 is the base. Okay. 2 is the index or the log. So let's see. Log of the number here. All right. Log of 9 to base 3 is equal to 2. Okay. So we have raised 3 to the power of 2 to find 9. Now we want to find the log or the index, the number that this base was raised to. Okay. Now, remember the term or the way in which you are saying this. We say log of 9 to base 3 is equal to 2. Okay? Now, let's have a look at a couple of examples to see how we translate index form to logarithm form. All right? Now, let's have a look at the number or the index 10 to the power of 4. Okay, this is equal to 10,000. Now, write this in log form. Now, we can see that our base is 10, our index is 4, and here is the given number. So, in log form, log of 10,000 to base 10 is equal to the index of 4. All right? Now, vice versa, if I give you a logarithm, you should be able to give me its index form. Remember, logarithm and index are inverse operations, very similar to add and subtract or multiply and divide. Okay, so the next example, let's see. This is example 2. Sorry, let's just be clear here. All right. Log of 8 to base 2 equal to 3. All right. Rewrite this as or in index form. Again, this is your base. This is the index, and this is the given number. So, you are going to rewrite this as 2 to the power of 3 is equal to 8. Okay? Now, let's go to something a little bit or a step little bit more than what is given here. This is very basic. All right? Now, example 3. Example 4, excuse me. Let's have a look at evaluating, all right, log of 81 to base 3. Okay, now when I write evaluate, I am asking for us to express 81 in index form with the base of 3. Okay, express 81 in index form with a base of 3. Okay, now you already know this, that 9 squared is equal to 81. All right, now 9 is not the base that we are asking for. It says evaluate with base of 3. So we know that 9 is a square number. This is 3 to the power of 2 will give us 9. So you put that in brackets and multiply again by this index to give you 81. So with a base of 3, will be raised to a power of 4 to give you 81. All right. So our answer here, hold on. We have to have log here. All right, log of, there we go. Now it's looking correct. Okay, so our answer will be 4. Okay, the index. All right, so this is basically how logarithms and index are inverse. You can write them vice versa in index form or as a log. All right, now we're going to move in quickly to the first law of index, which is, let's see, index law number 1. Let's write it down, which states that when you're multiplying two numbers with the same base, we add the index, okay? So let's see, a to the power of m times a to the power of n is equal to m plus n. That's what the index law states. Now, how does this relate to the logarithm law? Okay, now logarithm law number 1, all right, states that the sum of two logs, all right? I'm going to write this very condensed. Sum of two logs, okay, with the same base, all right? If we get the sum of two logs with the same base, then this is equal to, all right, hold on, the logarithm of the products, all right, product of numbers, okay? So our law states that the sum of two logs with the same base is equal to the log of the product of numbers. Now, which numbers? It is the numbers that appear in the log itself, okay? So let's have a look at assigning some letters to this. We'll see how the rule looks like in log terms. Okay, so we have log of x, okay, log of x to base a plus log of y to base a is equal to log of xy, the product, to the same base, okay? So that's what the law says. If I add two logs that have the same base, then the result will be the product of these two numbers to the same base, okay? Now remember, logs are inverse to index. So in index where we multiply, then add, in logs we are adding, then multiplying. Okay, so let's add in some numbers and see. We have the next example. Evaluate log 20 to base 10, all right, plus log 5 to base 10, okay? Now, you can see we are adding two logs and the base is the same. So that means when we add the bases or add the logs, we are going to multiply the two numbers there. Okay, so let's see. Log, in brackets, 20 times 5 to base 10. Okay, all right. Then log 20 times 5 is 100. Log of 100 to base 10. We already know 100 is the result of multiplying 10 times 10. So that's what we are going to write. Log of 10 to the power of 2, all right, to base 10. Your final answer is the index of 2, okay? So instead of using the index to get the result, we are using the result to find the index or the power. And that power in this topic is known as the log. Okay? Now, in the olden days, there were no calculators. So believe it or not, all of this was done using the brain. Okay? Remember that logs are inverse to index. So if you know the index laws, the log laws will not be difficult to understand. I hope you can join me in our next lesson where we will move on to the next couple of laws under logarithms. Join me then.